Hello, Bill Selk here, and welcome to Desktop Engineering's Innovator in the Room. It's a new series, but we're going to be covering a lot of very compelling, very interesting topics. And with me here today to join us on this program, Steve Robbins, and you're the executive editor. What are we trying to accomplish with Innovator in the Room?
As you know, DE magazine has been covering technologies for design engineers for 15 years now. And what we have found through the years that there are always really great new products that are coming out, new things that enable and help engineers to do their jobs. The best way to explain these is often not looking at a press release or something like that, but to have a video and watch the machines work. Like today, we'll be working with 3D printing, and you really can understand 3D printing when you see it working.
Right.
And we cover a number of subjects in DE, but the main areas that we try to stay in is design software, simulation and analysis, the rapid technologies, including 3D printing and scanning, and then the enabling technologies like high-performance computing and the workstations that engineers use. All of these products help design engineers to optimize their work life. And it's important that we are able to communicate well with these. So that's the reason we are talking about the Innovator in the Room.
With Innovator in the Room, we'll actually, in the series, be actually going out. So we'll go to some industry conferences and trade shows. We'll go to people's offices and factories in the plant and actually experience some of these things.
Yeah, I would hope so. It'll be a lot of fun doing that.
It will,
yes.
Well, it's going to be a great program, and we can start today with our guest. And they're coming from Objet, and let's bring in Bruce at this point. And Bruce Bradshaw, Director of Marketing with Objet. Talk a little bit about where we are today, Steve.
Just recently, I've had the opportunity to attend the Additive Manufacturing Users Group convention in California, and there I met a number of people, both users of Objet technology and some people from the home office in Israel. And we had a lot of great information that we recorded there. So what I do is I want to show the information that we have done after Bruce and I talk a little bit about digital materials, because Bruce has some new information to tell us on what's going on at Objet with digital materials.
Yeah, actually, Steve, we actually just introduced several new materials, actually 39 in total. You'll hear Zehavit talk about it a little bit from your interview with her in California, the way digital materials come about, but we actually introduced 39 new digital materials, basically made up of our Vero Clear material, which we can talk a little bit more, and our rubber-like material, which is a Tango. So by combining those two materials, you get a set of 20. We also introduced the ability to blend the rubber-like material with our high-temperature material. So if somebody is, you're Keurig and you're doing a coffee maker and you want to do a clear part of the coffee pot with running hot water through it, you can now do that with high temperature material and the rubber-like.
So Bruce, what's the total number of materials you have now?
Interestingly enough, Steve, it's a great question. We're now at 107 materials, which is revolutionary in the rapid prototyping and additive manufacturing space. Most of the technologies allow you 5 in that range, maybe some variants on colors. Between our materials, the different mix of base materials, by blending those together in the Connex technology, we now have the ability to produce 107 different materials or mechanical properties.
When I got a chance to talk to Zehavit Reisin at the AMUG show, she was discussing how both flexibility and strength and also heat and heat resistance were very important to the materials that you were building.
Correct.
There are some great applications that you can do by combining those kind of materials into, say, strength and resistance to heat.
Correct. It's one of the key attributes of the Connex technology is you can take two base materials, one that is very tough, and one of the classic issues with a tough material is typically it's not heat resistant at all, so it warps, and combine that with a high temperature material, and those characteristics for that, if it was standalone, typically are brittle, so they break easily. By taking the two best characteristics of those and combining them into one material through the Connex technology, you get the best of both worlds. So it's an interesting technology that allows customers to get much more flexibility, much greater usability, much more application use from their prototypes by combining those.
Right. And these are true digital materials.
Correct.
In other words, you're not putting down those materials, you're actually creating them on the bed.
Yeah, exactly. It's an interesting concept there as well, because much like a two-dimensional inkjet printer, when you talk about color, to get 256 different color combinations, you have to lay the colors down in a precise way. Well, we do the same thing with the drops of resin, but we're doing them in a three-dimensional space. So you're combining three different dots in various combinations to get a different mechanical property. So for instance, if I'm trying to get in this one something that's got some flexibility to it, but it also has a rigid feel to it, it takes a precise way of laying down those dots in order to get that, versus going to the softer variant in this particular case, where the combination of those materials is very scientific and precise. It's not just laying dot by dot, it's actually putting them in a precise pattern to get a desired feel.
Yeah, I noticed that you have something here that was a prototype for Tupperware?
Rubbermaid.
Rubbermaid, boy.
That's okay.
And they were trying to determine how the flexibility should be on the sandwich container here.
Right.
And I know that the audience can't feel this, but you can really quickly tell what kind of material that you want to use on this just by feeling it.
Sure. So, I mean, in the previous way or prior to Connex technology, they could print one of these things out with our Tango material, so it would give them a soft feel, and they would have to print out 4 different versions of this. By combining these materials, I can now get 4 different shore values or softnesses for these corners, and in one prototype be able to determine what the best softness is, what feel I want for that, what's going to click and seal that container the best. So actually having the ability to do that in a single prototype speeds up their development cycle, allows them to spend less money on materials in the prototyping stage, and helps them get their product to market faster.
And Bruce, can you do this in the Connex line of printers, but can you do it in the Eden line also?
No, it's actually, I'll clarify that for you. Our Connex line allows you to take 2 base materials and combine them to get those 107 materials we talked about. Our Eden line allows you to print both flexible and rigid materials, but it's only the base materials. So there's 17 base materials that we have, a combination of different rigid and rubber-like materials, polypropylene. You can print those one off. I think you have an example there as a shoe sole. That's printed in our Eden line. That's a single rubber-like material, but I don't have the ability to combine that. And in our desktop line, our entry-level machine is about $20,000, and it prints just a single Vero white material, but it clearly gets folks the ability to prototype in a very professional way with high quality, the same as our high-end machines, but with a single material at a very affordable price. That's in our desktop line. Our high end of the desktop line gives you all the rigid material plus clear and high temperature.
Yeah. Well, I know we're going to see some great videos here.
Yeah.
I think one of the key things to kind of take away from these videos when you listen to both Zehavit and the people that are in the case studies are that it isn't just the materials and the things that you're printing, it's the optimization of the whole design process that you're doing too. That you can do things better and you can do them quickly without having to decide to go to somebody and build plastic prototypes, or even when you're using 3D printing to be able to put something like this together where you have 3 or 4 materials,
right,
and you're able to sit around and figure out which one's going to work quickly.
It is so common for, I can almost say 100% of our customer base, all that would probably be a little bit of an exaggeration, but very, very common that our customer base, once they get the printer and they start using it, say that they prototype way more, and that extra prototype, so those additional prototypes, allow them to get their products to market faster, and it allows them to improve the quality of the design. And they just didn't experience that before having a 3D printer at their disposal.
Yeah. Great technology.
Well, let's take a look at the clip, the interview that you conducted with Zehavit out in Costa Mesa.
Great, Bill. Here we are in Costa Mesa, California, with Zehavit from Objet, and we are at the Additive Manufacturing Users Group meeting, and we're here today to talk about new materials that Objet has, great technology. Zehavit, I was wondering if you could explain what digital materials are and when you started making these materials and how these materials have been used in the last few years.
Okay, so first of all, before digital materials, we had cartridge-based materials, and here I'm holding just our keychain of cartridge-based materials, which are used intensively today by our desktop, Eden, as well as Connex systems users. But it was December 2007 when we launched something new. That was the digital materials. Just to understand what's going on here. So we are all familiar with our rigid white material. This is a part made of very white plus, and our rubber-like Tango Black Plus Short 27 material. Now, when you take it to a platform which is capable of jetting simultaneously two modeling materials, say one of them is rigid and one of them is rubber-like, that's exactly where you end up with something new. What is the new thing? These are the digital materials. Here we can see a piece made of the rigid white material, and here with the rubber-like Tango Black Plus material. Everything that we see in between are digital materials which are software-based compositions made exactly from those two cartridge-based materials. In this case, all these compositions are made so the very white plus, the rigid white material, is the primary one, the dominant one. And with each material here, we are adding and composing more of Tango Black Plus, meaning we are adding rubber-like material to a rigid one, which makes those materials with shock absorption properties, with more properties that tends the last one to act as polypropylene and not just a regular Vero. So all these materials that you see in between do not exist in the cartridge, but they do exist on parts like that. And Steve, you know, just using the very same cartridges, again, the same white cartridge and rubber-like black one, this time when the software takes in account that this one would be the dominant, and we are adding a little bit of more rigid white material, that's where we end up with a wide range of shore values, of hardness values that are being built, again, by software. So those materials here do not exist in the cartridge, but yes, they do exist in a part. So this technology is capable, just by putting Vero White Plus and Tango Black Plus in the system, to generate 14 different properties in a single part. Think about it, that's amazing.
And yes, that actually is quite amazing. Steve, when you do this kind of a blend in this mixture, it gives an incredible number of opportunities for people, different kinds of products and prototyping that you know, really you cannot duplicate this any other ways. But let's see what else, a little bit more about that now.
Yeah, it's very interesting. The next clip is about David Gurrola, who works for GROWit. And David is creating prototypes that are really used in the real world. They are exposed to sunlight and they test things with them and they do things that are really incredible because they have properties that they can build on the fly. And I think Bruce could probably tell us a little more about how David does that.
Sure. As you mentioned, you know, the ability to blend the materials and to do different things allow you all kinds of flexibilities. David does a lot of work in the automotive space. I think he'll touch on that. But as an example, the new materials that we just referenced as being new to Objet, part of the 107 material suite, is the ability to combine a clear material and a rubber-like material. So in the automotive space, if I'm building a lens and I now want to produce that gasket at the same time and I want to test that on an automobile, I now have the ability to print that part all at once. Or if I'm not quite sure how soft this should be, or you know what the shore value should be of that rubber, I can print 5 different versions of these and put them on and see what
different sizes,
exactly
different strengths here.
And again, you can print those all at once, all at the same tray, print them all at the same time because it's just combining the rubber-like material with the clear material in this case. There's other examples like in the medical space where you can actually take a CT scan or an MRI scan of a patient, and we've actually spoken with doctors that will take a person's liver that actually has cancer, and they'll output that, and they'll be able to see the bile ducts of that liver, so they know and can understand exactly where they need to operate on, so they don't actually kill the patient on the operating table by accidentally cutting a bile duct. They can also move it like a real liver would be. So being able to do this in many, many different applications, again, automotive, medical, consumer electronics, consumer goods, is really an advantage. And again, the Connex technology allows that.
Let's see what David has to say.
We have today David Gurrola from GROWit. Hi, David. How are you today?
Nice to meet you.
Nice meeting you too. So when was the first time you heard about Objet ABS-like material?
We heard about it in about April last year. We were, I believe, one of the first users, and we jumped right on the case of being able to use it. We're big in the automotive industry, So a lot of high detail components for accessories and grill components and things like that. So we were able to take a lot of the applications that we had to do a lot of finishing on that are right around the engines, see a lot of force from aerodynamic loads, and we're able to take the ABS-like material and directly implement it into that application where they're chrome plating the parts and painting the parts and things like that.
So that's quite a wide range of new applications, I would say, that possibly before you did it with other technologies.
It saved us a lot of time. Before we were doing a lot of dash components and things like that, primarily in our FDM technologies, and it takes a lot of time to finish those parts out. We did have a situation where one of our employees dropped off some ABS parts at the plating house, and he just had a set of 220 grit sandpaper in his car, and it was so rushed that we didn't get the chance to sand them. He was able to stand them up right there in the parking lot, and they came out great. There's no way you could do that with any other technology in the layer lines.
Fantastic. So what is most appealing for your applications? Is it the toughness of the ABS-like material, the fact that its isode impact is 65 to 75 joule per meter, or it's about the heat resistance, which reaches 65 degrees out of the printer, and then you probably know that you could thermally post-cure it and get to 90 and even 100 degrees Celsius?
So I think the primary for us is the stability. We would commonly see applications where we'd have mold masters that we'd have around for a year and a half, and we'd start seeing some distortion, things like that. Now we can do that for extended periods of time with the stability of the material. Next would primarily be the temperature. Okay. We are doing a lot to post-cure our parts in sand beds and things like that, so we can do some very detailed, very large parts in post-curing without having to worry about elevated temperature warpage during the post-curing process, and that's been great. We've been able to do some very fine detailed parts and even see elevated temperatures in usage after post-curing, and sometimes higher than what the spec sheets say, depending on how well we post-cure.
What about your end users? Do they already request for the ABS-like, or they are still kind of hesitating about it?
No, a lot of our users that first came to us looking for the high temp material, the white material, okay. Because that was kind of, I think, out there first. We immediately introduced them into the ABS-like because we were primarily using that more, and they were just ecstatic about it. Okay. So they have adopted it very openly for very small components, large components, hybrid tooling, things like that. So
some excellent examples there, and David's direction that he's going with here, it really is interesting to see what's going on. So 3D printing, a lot of opportunity.
Yeah, definitely, and a lot of advantage here. You can see that David saved a lot of time and money with what he was doing, didn't he, Bruce?
He did, and you know, it's very common for folks to understand the value of a prototype, and many folks understand and outsource and get their prototypes from companies like GROWit and other service bureaus. But the advantage of having a 3D printer in-house allows people to do something, makes them think a little different. Most people are using a prototype today for design verification. Did it look the way I want, you know? Does it feel the way I want? As opposed to a tool to allow them to improve their design. So they're now using it to check their design at the end, as opposed to improving their design when they have a 3D printer at their fingertips. Again, it speeds up their development process. It allows them to say, you know, had I seen this prototype 4 weeks ago, I would have changed this grip because it doesn't actually fit the way I want, but it's too late now, so I have to get this out. But you know what? It's okay. Had they had a 3D printer in-house, they'd change that design, they'd print 5 versions of these, 6 versions of these, and they would improve their design immensely. And it's a very, very common thing we see after people get the printer. The trick is for people to understand that and adopt 3D printing more rapidly because of that.
Yep.
And it's a cost-effective method to be able to do this. It's not really going to break the bank once you have the printer, just to keep testing and tweaking things.
Absolutely. You know, the cost of an outsourced prototype versus buying it on your own or having the technology at your fingertips is very cost effective. On top of that, if you, again, it varies company by company, product by product, but the quicker I can get a product to market, the faster I can start bringing revenue into the company. Things like that impact the bottom line that people don't often take into the equation as well, but it's an important factor.
And then once you're making these edits, the time to actually click print, it comes up pretty quickly.
Yeah, it does, exactly. Yeah. It's about a half an inch an hour in the Z direction to print a part. So
not bad. Well, thank you, Bruce. Thank you, Steve. This is the first edition of Innovator in the Room with Desktop Engineering Magazine. We want to thank you for joining us today. Certainly a lot more information at objet.com and Desktop Engineering's site and Innovator in the Room pages on the Desktop Engineering site. So thank you for joining us today.